Okay, so the real question is, over the past 2 weeks, we have learned the rational root theorem, which allows us to generate a list of possible rational roots for a polynomial that doesn't factor. We've used the Descartes rule of sign, which helps us tell us how many positive and negative numbers, roots that a polynomial will have. We've also used the remainder theorem, which would actually help us find the zeros or the x-intercepts of the polynomial. In calculus, you will learn how to take the derivative of this and find the actual turning points. We're not going to do that on this video. But we've also talked about end behavior before of this polynomial. So now we're going to actually ask you to graph this polynomial, given, that you won't be precise on the in-betweens, but you'll know how many places, how it turns, where it crosses the x-axis, where it's going to touch and turn the x-axis or pass through. So let's just kind of dive into this. So the first thing I want to look at is I'm going to look and see the end behavior. So my end behavior for this function, I know as the limit as x approaches infinity of my function and the limit as x approaches negative infinity of this function. So this is my end behavior. So my leading coefficient is 4, so that's positive, and my degree is odd. So that tells me that my graph is going to do something like this. It's going down and then up. So as I'm approaching infinity, my y is going to be approaching infinity, and as I'm going towards negative infinity, my y is going to be approaching negative infinity. So that's my end behavior of this graph. Now, the number of turning points, I haven't talked about those in the other videos, but this is very straightforward. The number of turning points is you're going to do your degree minus 1. So my degree of this polynomial is 3. So with the degree being 3, I'm just simply define my turning points. I'm going to do degree minus 1. So I'm going to have 2 turning points. So this graph is going to turn in 2 places. My y-intercept is easy to find. My y-intercept, I plug 0 in for this, so I put 0 for all of my x's, and I'm going to get 3 for my y. So keep that in mind. We now have my end behavior, I have my y-intercept, and I know this graph has to turn in 2 different places. The hard one to figure out is the x-intercepts, and that's what we've been kind of building up to. To find the x-intercepts, we actually need to solve this. So we need to do 0 equals 4x cubed minus 8 x squared plus x plus 3. And I'm going to look real quick to see if I can factor this by grouping because it's 4 terms. If I group these first 2, it has a 4x squared in common, and that's going to leave me an x minus 2, but I'm not going to get an x minus 2 out of my second group, so I can't factor this by grouping. So now I have to go to my rational root theorem. So my rational root theorem, we're going to get our q from here and our p from here. So we're going to do p divided by q, which is going to be plus or minus 1 over plus or minus 3 over plus or minus 1, plus or minus 2, and plus or minus 4. So my actual list ends up being plus or minus 1, plus or minus 2, plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, and then plus or minus 3/4. Okay, so there's my list of possible rational roots. It's significantly long. So I'm going to use the Descartes rule of sign to kind of narrow this down. So for my positive solutions, I've got a positive to a negative, that's 1. I have a negative to a positive, that's 2. And a positive to a positive. So I have 2 or 0 positive solutions. Well, that doesn't really help me. That means in this list there could be 2 or there could be 0. That would really kind of suck. To do all of the positives first and it not actually work out. So let's do the negatives. So the negatives mean I'm going to have to change all this. I'm going to go in and put negative x in. So if I put a negative x here, this becomes a negative 4x cubed. If I put a negative here, this is negative 8x squared. If I put a negative, I have a negative x, and then plus 3. So now I'm going to look. I have no change there, no change here, and 1 change. So I have 1 negative solution. All right. So from here, what I would do is I wouldn't start with my positives because I may have 0 positives. But I'm guaranteed to have 1 negative, so I'm going to do all my negatives. And from that, I'm going to use the remainder theorem. Okay, so I went ahead and evaluated, and I took a bunch of those different numbers and plugged them in to find 0 by using the remainder theorem. So you can see I did f of negative 3/4, and that didn't work. 3/4 didn't work. F of negative 1/4 didn't work. But I did find one at f equals 3/2. So what this really tells me is that I can have one of my intercepts. If I have x equals 3/2, I can multiply by 2. I have 2x equals 3. Subtract 3. 2x minus 3 equals 0. All right. So now I can reduce my polynomial. So my polynomial, which I erased like a dummy, is 4x cubed minus 8x squared plus x plus 3. And I'm going to do synthetic division, and I'm going to do that number right there. So I'm going to do 3/2 as my multiplier, and I'm going to, these are already in order, so I've got 4, -8, 1, and 3. What's nice about the remainder theorem is I know that this needs to be 0. That's why we were doing the remainder, because if not, all these other ones would be this number in the box. So I'm going to bring down my 4, and 3/2 times 4 is going to give me 6. I'm going to add, this gives me -2. This is going to give me -3. I'm going to add, this gives me -2. And when I multiply, this gives me -3. So voila. Now, if you remember, these reduces down. So I have 4x squared minus 2x minus 2. And then from here, let's see if we can solve this real quick. We can take out a 2. This gives me a 2x squared minus x minus 1 equals 0. Divide everything by that. 2x squared minus x minus 1 equals 0. And then this should factor because I've got a -2, which is going to factor to 2x squared minus 2x plus x minus 1 equals 0. Group them. Take my 2x out. That leaves me with x minus 1 plus 1 gives me x minus 1. And from here we have 2x plus 1, and then x minus 1 equals 0. Therefore, my x's are going to be a -1/2 and a 1. So I have my 3 x-intercepts, my x-intercepts. All right. Now that we have found the x-intercepts, we can go back and we can get a rough idea of what this graph is going to look like. Here I have the end behavior. We know that as it's going right on the graph, it's going up forever. That's what this is saying, is the limit as x approaches infinity of my function is going to infinity. And as we're going left on the graph, that's what this part's saying, and that is the limit as x is approaching negative infinity of f of x is going to negative infinity, meaning it's going down. I know I'm going to have 2 turning points. I have a y-intercept at 0, 3 by simply just plugging 0 in for all of my x's. And then my x-intercepts are going to be 3/2, -1/2, and 1. So what we're going to do is we're actually going to graph this at this point. So, well, let's do this. 0, 3. Let's call this 0, 3. So 0, 3. We have a x-intercept right here at -1/2. We're going to have another one right here. Let's call this 3/2. Well, let's call that 1. And another one, let's call that right here. Let's call this 3/2. Now, the multiplicities of each of these are just 1, so their odds is going to be passing through. I know my end behavior is coming down like this, and it's coming up like this, based on my end behavior. I need to have 2 turning points. In this case, it's actually coming up to here, coming down and through, and then it's turning back up here. Now to find this point and actually this point where it actually turns, you need calculus to find that out. We're in pre-cal, so just kind of rough estimate where the turning points are. As long as you have the right number of turning points and the graph's kind of okay with your end behavior, your x-intercept and y-intercepts, I'm not going to take off if your turning points are in the wrong spot. All right, and there is the graph of 4x cubed minus 8x squared plus x plus 3. Not a terrible process of going through. In calculus, you'll learn how to find those turning points, and then you'll be able to graph these precisely to know exactly where everything is turning, and we have changes in concavity and inflection points and everything else. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.